Hello and welcome, students. Today we are going to start with the topic circle, and this is a part of coordinate geometry. Remember, this topic circle, it is a part of coordinate geometry. Now, what is important here that when you take the topic circle, under coordinate geometry, then the treatment of the topic is different. That is, you learn several things in a different way. I repeat again, when you are taking the topic circle under coordinate geometry, then you learn several things in a different way. If you remember, you had already done circle in 10th standard. In 10th standard also, you have done the topic circle. But in 10th standard, when you did circle, it was not under coordinate geometry. In 11th standard, you are doing circle under coordinate geometry. So in 10th standard, when we did circle, in 10th standard, when we had done circle, we did circle under pure geometry, simply geometry. Okay. So we had several things, there. We studied the tangents to the circle, the chord of the circle. That was all pure geometry. Pure geometry. The tangents, the chords, the intersecting chords, the intersecting tangent, several things. We are going to study everything once again, but now we are going to study under coordinate geometry. Okay. Now, what is coordinate geometry? This we have already done. Coordinate geometry is basically, in short, if you want to say what is coordinate geometry. Okay, see, in coordinate geometry, if you want to define coordinate geometry in one simple statement, you will say learning geometry with the help of algebra, is known as coordinate geometry. So what is coordinate geometry? Very simple. When you are learning geometry, for learning geometry, you are taking help of algebra. With the help of algebra, you are learning geometry with the help of algebra. So you will call that as coordinate geometry. Okay. So let us study, students. See, we have already done topics like locus. Earlier to this, we have done locus. We have done straight lines. Now we are going to start with topic circle. Listen. See here, students. What are the things that we have to study in circle? See, first of all, define a circle. So what is a circle? How will you define a circle? See, a circle, here it is defined, you can check. A circle is a set of all points in a plane which are equidistant from a fixed point in the plane. So you have to define a circle. How will you define? So for defining a circle, you can say that this is plane, suppose this is plane, and now in this plane you have a fixed point, right? Now set off all those points which are equidistant from this fixed point. So define a distance. Okay, define a distance. Now take all those points which are equidistant from this fixed point. Which fixed point? The red one. is a fixed point. So if I take points which are equidistant, so say some distance you decided, and the distance you decided is say 5 units. So this is 5 units. Okay. Red point. This red point is the fixed point, and from red point, this point is 5 units. Okay. Now you take another point at 5 units, then take another point at 5 units, 5 units, 5 units, 5 units. All points which are at a distance of 5 units from this point. And what will you get? You will get a you will get set of points. You will get set of points. You will get set, S-E-T. You will get set of points which are all equidistant, from the fixed point. What is the fixed point? This red one, the red point is the fixed point. And these blue points are all points which are at a distance of 5 units. Okay. So what will happen? Finally, you will end up getting a circle, something like this. Fixed point, and these all points are at a distance of 5 units from fixed point. Okay. So, these all points are so close to each other. They are so close to each other that you see them as a continuous point. But they are all different points. But then they are so close to each other that you see them as a continuous point. You know, these points are actually, there are infinite points, but they are so close to each other that you see them. There are infinite points, and those points are so close to each other that you see a continuous curve, because there are infinite points and those points are very, very, very close to each other. So what do you see? You see you see a continuous curve. So this is fixed point. This is fixed point. This point is fixed point. Okay. Let us call this fixed point as C, the center C. And then you can take, these all points are variable points. You can select any point from these points. Say I select this point. Okay. Let us call this point as P. What is P? P is a variable point. I will take P as x comma y. I will take P as x comma y. And the center, I will take center of the circle, which is fixed point. Fixed point is the center. And P is a variable point. Why I said P is a variable point? Because it can be anywhere on the circle. It can be anywhere on the circle, anywhere. In fact, I myself did not know whether I'm going to take it here, or I will take it here, or I will take it here, or I will take it here. You can take anywhere on the circle. So point P can be anywhere on the circle. That's why we call it as variable point. Now this distance C to P is known as radius. CP is known as radius. Okay. This coordinate, the point C, which is fixed point. Now, since it is a fixed point, it will have fixed coordinates, and we will call the coordinates as h comma k. Coordinates of point C are fixed. Please understand. Coordinates of point C are fixed, h comma k. They are not changing. Point C is not changing. Point C will remain always where it is. It will always remain here. So the coordinates will remain constant. Coordinates are constant. But point P will keep changing. And since P is changing, remember that coordinates of point P will keep changing. That is why we call it as x comma y. The distance CP is also constant because that is radius. Okay, that will always remain same. So now what I will do is, see here. I write CP, length CP is equal to R. What is length CP? It is equal to R. Now I will apply distance formula. So distance formula, by distance formula, I can write length CP. I can apply distance formula for CP. Correct? Yes. I can apply distance formula for CP. So students, see here, I wrote point C. I wrote point CH comma K is the center of the circle, right? Then I wrote Px comma Y is a variable point on the circle. CP is the radius of the circle, which is equal to R. So what I can write? I can write length CP is equal to R. Now I will apply distance formula, right? So here I write by distance formula. By distance formula. What is distance formula? When you know the coordinates, when you know the coordinates of 2 points, then you can get the distance between the 2 points by this formula. See here, CP, length CP, you know the coordinates of C, you know the coordinates of P. So CP will be square root of x2 minus x1 square. So x minus h the whole square, difference of x coordinates, plus y minus k the whole square, difference of y coordinates, y minus k the whole square equals to R. Now what I will do? Squaring both sides. I will write here squaring both sides. I will square both sides. So when you square both sides, what you get? You get your x minus h square plus y minus k square is equal to R square. And please understand, students, this is important. This is important. You know what is it? It is the equation of circle. We will call this as, see, I will call this as, this is equation of circle in center radius form. In center radius form. Please understand. What is this? It is equation of circle in center radius form. Center radius form. You know the center of the circle. You know the radius of the circle. So you can write the equation this way. Very, very, very important. Okay. Please copy this equation of circle in center radius form. You can give the heading also. You can give the heading also. Equation of circle in center radius form. So students, this equation that you have here, it is equation of the circle in center radius form. X minus h square plus y minus k square is equal to R square. Now see here. What is h? H is the x coordinate of the center. What is k? K, it is the y coordinate of the center. And what is R? And what is R? It is the radius of the circle. Okay. What are x and y? What are x and y? They are the coordinates of variable points which can be anywhere. Here, don't think that variable point is always here. It can be here, 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 here. It can be anywhere, and that is why the coordinates are x comma y. So once again, Equation of circle in center radius form is x minus h square plus y minus k square is equal to r square. X minus h square plus y minus k square is equal to r square. And if you are asking, sir, where will the x and y axis be? You have not drawn the x and y axis. You can say, sir, you write the coordinates, but where are x and y axis? You can draw it. See, this is say your y axis, and you have here x axis. Yes, y and x axis can be like this. So this is your y axis, this is origin, this is x axis. Not required. Okay. Yes. Now here I have something very interesting. Students, think if the x-axis and y-axis are such that the center of the circle lies on the origin. Just think, if the x and y-axis are such, if the x and y-axis are such that center of the circle lies on the origin. In that case, what will happen? In that case, this is center, try to understand. In that case, this is center, and the coordinates of the center will be 0, comma 0. What will be the coordinates? 0, comma 0. You understand? If the x and y axis, if the x and y axis are such that center of the circle lies on the origin. In such a case, what will happen? In such a case, you will say the coordinates of center are 0, 0. Okay, let me show it to you. Think this is a circle. Okay, and here you have the x-axis, you have y-axis, and center. What is center? Origin, 0, comma 0. And the variable point is here, p, x, comma, y. The radius is r. What is the radius? R. This is radius. Okay. Y-axis, x-axis. Now I will write the equation of the circle. So tell me, if I write the equation of circle, see what I will say. I will first write point O00. You see this? Point O00 is the center of the circle. Pxy is a variable point. Then I will write OP is the radius. OP is radius of the circle, which is r. So what is OP? OP is equal to r by distance formula. Now I will apply distance formula. Correct? So see, when I will apply distance formula, what am I going to get? You will all see here. What am I going to get? See, let me apply the distance formula. So Distance formula for OP. The difference of x coordinates. So x minus 0 square plus y minus 0. Y minus 0 square is up. Now I write here. Therefore, square root of x minus 0 is x. So x square plus y square is r. So I have, now I write squaring both sides. Squaring both sides. When I square both sides, what do I get? I get x square plus y square is equal to r square. And what is this? This is equation of circle. Equation of circle in standard form. Which form? Standard form. Why do we call this a standard form? Simple. Because the center is at the origin. The center of the circle is at the origin. You can copy this also. Thing here is equation of circle in standard form. Equation of circle in standard form. What is the equation of circle in standard form? Very simple. X square plus y square is equal to r square. X square plus y square is equal to r square. Very, very, very simple. Okay, so students, see, let us solve problem here. Look at this question. It says find the equation of circle with center at origin radius 4. This you will solve in standard form. Center at -3, -2 and radius 6. This you will solve. Here you will write the equation of circle in center radius form. Center at 2, -3 and radius 5. Here also you will solve this in equation you will write in center radius form. So you know the amongst these 4 problems, I think the problem worthy of being discussed is question number 4. If I solve 4th question, rest of the questions you can solve on your own. So here I will take the 4th one. See, it says, question number 4 says, center at -3, -3, center at -3, -3, passing through -3, -6. Okay, so I draw the circle. The center is at -3, -3. Center of the circle is at -3, -3. And passing through point -3, -6. The circle is passing through a point -3, -6. This point -3, -6 is on the circle. Let us call this point as P. So students, I know the center of the circle. I know the center of the circle and I know one point on the circle. Why? Because they are saying passing through the point. The circle is passing through this point. You can check. The circle is passing through this point. So I know the coordinates of center. I know one point on the circle, but I do not know the radius of the circle. You know, students, because I do not know the radius of the circle, I cannot apply center radius form. I cannot apply center radius form because I do not know the radius of the circle. But can I find the radius of the circle? Yes, I can find the radius of the circle. You know how I will write radius of the circle is length CP. This is the radius of the circle. And I will apply distance formula. I will write here radius of circle is equal to CP. That is equal to square root of, I will apply distance formula, x2 minus x1 square, -3 minus of minus 3. So minus 3 minus of minus 3 the whole square. Difference of x coordinates plus minus 6 minus of minus 3 the whole square. So what do I get? I get square root of, see this becomes minus 3 plus 3, minus 3 plus 3 square plus minus 6 plus 3 square. So this becomes 0 square. So square root of 0 square is 0 plus minus 3 square is 9. This is minus 3 square, that is 9. Square root of 9 is 3. So I got the radius. So see here, I got the radius as 3. Can I now get the equation? Yes. I will write, therefore, I'll write here, therefore, the equation of circle, therefore, the equation of circle in center radius form, equation of circle in center radius form is what it is. You know, x minus x coordinate of the center, x minus minus 3 square plus y minus minus 3 square is equal to r square, that is 3 square. That is 3 square. Or that, so you will get here x plus 3 the whole square plus y plus 3 the whole square equals to 9. So x square plus 6x plus 9 plus y square plus 6y plus 9 equals to 9. This 9, 1 9 cancels. So x square plus y square plus 6x plus 6y plus 9 equal to 0. This is the required equation of circle. Come on, do it. So students, now see this question number 4. We are solving question number 4 now. In question number 4, what they are giving? The question is, find the equation of circle if the equations of two diameters are 2x plus y equals to 6, 3x plus 2y equals to 4, when radius of circle is 9. See students, for the circle, what they give us is two diameters. See, this is one diameter and here the other diameter. Where will the two diameter intersect each other? You know, the diameters will intersect each other at the origin. So this is the point of intersection. You know, students, both the diameters are straight lines. Diameters are always straight lines. So they give us the equation of these two diameters. 2x plus y equal to 6 is equation of this diameter. 3x plus 2y equals to 4 is equation of this diameter. So these two diameters, which are straight lines, they are going to intersect each other at the center of the circle. You always know the two diameters will intersect each other at the center. Where will they intersect? At the center. Center. Because the diameter passes through the center. Now, they say the radius of circle is 9. The radius of the circle they are giving us as 9. So I know the radius, which is equal to 9, but I know the radius, which is equal to 9, but I don't know the center coordinates. I want the coordinates of the center. What I will do? Very simple. I understand that center is point of intersection. I will write here. See, center of the circle is point of intersection point of intersection of two diameters So how to get the coordinates of the point of intersection? I will solve these two diameters simultaneously. So I will write here solving the equations of diameters simultaneously. You know how to solve the two equations simultaneously? That is 2x plus y equal to 6 and 3x plus 2y equal to 4. Solve these two equations simultaneously. You will get the value of x and y. Remember, the two x values and y values that you got. X value will be the x coordinate and y value will be the y coordinate of their point of intersection. X and y will be the x and y coordinate of their point of intersection, which is nothing but the center. So you will get the equation, you will get the coordinates of the center. Okay. So come on, solve these two equations simultaneously. Do it. So students, when you will solve these two equations, you will get the x value as 8 and y value as -10. So x and y, after getting what you got, the point of intersection of these lines, you got the point of intersection of these two straight lines, which are diameters. So you will write therefore the coordinates of point of intersection are 8 comma -10, which is nothing but the center. So you got 8 comma -10 as the center. So after getting 8 comma -10 as center, now you can write the equation of the circle in center radius form. So you will say therefore the equation of the circle in center radius form. Therefore, equation of the circle in center radius form. Therefore, the equation of circle in center radius form is x minus 8 the whole square plus y minus of -10, that is y plus 10 the whole square equals to 9 square, r square. So just expand it and you will get the answer. X square minus 16x plus 64 plus y square plus 20y plus 100 equals to 81. So you will have x square plus y square minus 16x plus 20y. This becomes, see, this is 100. So you will get here plus 19. So plus 19. So plus 83 equals to 0. This is the answer. This is. Let us solve this question, students. This is question number 3rd, 4th sub-question. Question number 3, sub-question number 4. It says find the equation of the circle. I'll complete the question. Find the equation of circle having center at 3, 1 and touching the line 8x minus 15y plus 25 equal to 0. Okay. So let's draw the diagram first. See, this is circle. Where is its center? They say the center of the circle is at 3, 1. So this point, this point is 3, 1. Okay, this point which is center, let the center be C. What is the next thing that they are saying? They're saying that the circle is touching the line. Now, touching the line. So when they say line, what do they give? They give you the equation of line. So please understand that this equation, which is a linear equation in x and y, linear equation in x and y. You see this? All those equations which have x power 1, y power 1, they are equation of straight lines. They are equation of straight lines, okay? So they say the circle which is having center at 3, 1, it is touching the line 8x minus 15y plus 25 equals to 0. So, this is the line which the circle is touching. So what happens now? So what is this? This is the tangent. So this line is tangent. Now what I will do? I will join the center with the tangent and let this point be this point here, which is the point of contact. Okay, see, everybody knows, you all know that if a line is touching the circle, then the line is tangent to the circle. The line is tangent to the circle. So every tangent has a point of contact. Think the point of contact is P. This point is P here. What is this point? This point is P here, P. Okay. What I will do next? Now, students, now I am going to find the length CP. But the thing is, how do I find length CP? Listen, in straight lines, we have done a formula. What formula? The perpendicular distance formula. We have done a formula which is perpendicular distance formula. Now, according to that formula, if I know the coordinates, see, we all know that radius is always perpendicular to the tangent. We all know that radius is always perpendicular to the tangent. So we know that CP is perpendicular to the tangent, this line. I can find out CP now. I can find out CP by the formula. What is the formula? The formula is very, very, very simple. See, I will write, referring to the figure. I write here, referring to the figure below. Referring to the figure below. And I will write here CP. What is CP? CP is mod of. Okay. Now write the complete left-hand side. Write the complete left-hand side of the equation. Write the complete left-hand side of the equation. When I say left-hand side, I mean the right-hand side has to be 0. Okay, so by keeping the right-hand side 0, write the complete left-hand side of the equation in the numerator. And where you have x, you will write the x coordinate. Where you have y, you will write the y coordinate of the center. Okay. If you do that, you will get the distance of the point from the line. What do you want, students? You want distance of this point from this line. You want this distance. So what is the idea? The idea is very simple. You should have the equation of the line and you should know the coordinates of the point. If you know the equation of the line and you know the coordinates of the point, you can get the distance between the two. How? You will write mod of, and in the numerator, you will write 8. Don't write x, write 3. Minus 15, don't write y, write 1. Plus 25. You will write the whole numerator in the whole left-hand side, you will write the whole left-hand side in the numerator, and in place of x, write the x coordinate of the point, in place of y, write the y coordinate of the point, divided by square root of 8 square, that is the coefficient of x square, plus minus 15 square. So you will have CP is equal to 8 3s are 24 minus 15 plus 25 upon square root of 64 plus 225. So you got here 49. See, 25 plus 24 is 49. 49, or you can do this. This is 34 rather. 25 minus 15 is 10. 10 plus 24, 34. Divide by square root of 289. That is equal to 34 divided by 17. That is equal to mod of 2, which is 2. So what is CP? CP is 2. If CP is 2, therefore radius is 2. Radius is equal to 2. Now you got the radius of the circle. Do you have the center of the circle? Definitely yes. Definitely yes. This 3, 1 is the center of the circle. Can I now write the equation of the circle? Yes. I will write the equation of circle in center radius form. I will write therefore, the equation, I know the center, I know the radius. I will write the equation in center radius form. Therefore, the equation of circle in center radius form. In center radius form is what it is. It is x minus 3 square, x minus 3 square plus y minus 1 square equals to r square, which is 2 square. Just expand this and solve it. That's the final answer. I hope you all followed it. Solve question number 8 here. See, what does it say? Find the equation of a circle passing through points 1 minus 4, 5, 2. Find the equation of circle passing through points 1 minus 4. They give you 2 points on the circle. The circle is passing through these 2 points. When the circle is passing through these 2 points, that means these 2 points are lying on the circle, 1 minus 4 and 5, 2. And having its center on the line x minus 2y plus 9 equals to 0. So how will the diagram look like? See, the diagram will look like this. The circle is passing through these 2 points. Let me name those points as P and Q. So one point here on the circle P, the other point is Q. The circle is passing through these 2 points. The center of the circle, let us call it as C, it passes, and having its center, the circle has its center lying on this line, x minus 2y plus 9 equals to 0. So if the center is lying on a line, what does that mean? It means that the line is diameter. So x minus 2y, you see this? X minus 2y plus 9 equals to 0 is the line, it is the line on which the center lies. I have to get the equation of such a circle. I have to get equation of this circle. Now students, see, I know very simple thing. If I want equation of a circle, then I must know the center of the circle. I should have the coordinates of the center. I should have this and this number, x coordinate and y coordinate. Okay. And what more? I should have radius of the circle. I should have the radius. See, I do not have the radius also. Okay. So see, what do I do is, I will start solving this. See, let me first write the coordinates of the center. I will assume, since I have to find it, I will assume it as h comma k. So I will write, let the coordinates of center be h comma k. I write here my solution starts. See, the solution will also contain the diagram. The diagram will be inside the solution. So I will have let C h comma k be the center of the circle. Okay. Now see, if C h comma k is the center of the circle, I understand that I have to find the value of h and k. I have to find the value of h and k. What are h and k? They are unknowns. They are unknowns. H and k are unknowns. I have to find the value of these unknowns, h and k. How many unknowns I have? I have total two unknowns. So if I have to find the value of these two unknowns, what should I do? I must get two equations in h and k. I must get two equations in h and k. So see students, how do I go ahead? I will write. Since C h comma k lies on the line, it lies on the line x minus 2y plus 9 equal to 0. Therefore, therefore, the coordinates of CHK will satisfy the equation of line. See, this we have done in locus. What? When a point lies on a locus, then the coordinates of the point will satisfy equation of the locus. This we have done in locus. What we have done? When a point lies on a locus, when a point lies on a locus, then coordinates of the point will satisfy equation of the locus. See, what are the coordinates of the point h comma k? H comma k are the coordinates of this point, and this point is lying on this line whose equation is this. So the coordinates of this point, that is, in this line where I have x, I can put h, and where I have y, I can put k. Got that? So here I will write here. Therefore, h minus 2y, you know what I'm doing? H minus 2k, I'm putting h and k in place of x and y. H minus 2k plus 9 equal to 0. That is h minus 2k equals to minus 9. This is equation number 1. See, I got one equation in h and k. I need one more equation in h and k. Okay. What will I do? See, very simple. Now I shall write. What I shall write is point C being the center. So distance of point Q from center and distance of point P from center will be equal. Okay, CP will be equal to CQ. I will get CP equal to CQ. You understand? So I will write here. Okay. Also CP is equal to CQ. Now I will apply the distance formula for CP and distance formula for CQ. So see here, h minus 1 the whole square, difference of x coordinate. You see this? I will get here h minus 1 the whole square plus h minus 1 the whole square plus k minus of minus 4, that is k plus 4 the whole square equals to h minus 5 the whole square plus k minus 2 the whole square, squaring both sides. Squaring both sides. So when you square both sides, what do you get? You get h minus 1 square plus k plus 4 square equals to h minus 5 square plus k minus 2 square. Okay? H minus 1 square plus k plus 4 square and h minus 5 square plus k minus 2 square. So this is h square minus 2h plus 1 plus k square plus 8k plus 16 is equal to h square minus 10h plus 25 plus k square minus 4k plus 4. Now, see here. This h square and h square will cancel. K square and k square will cancel. What do I have now? So I have here minus 2h plus 10h. Minus 2h plus 10h. This will go on the left. Plus 8k plus 4k. 8k plus 4k equals to, you have here 25 plus 4, 29 minus 17. 29 minus 17. So what do you have there for 8h plus 12k. 8h plus 12k equals to 22, 12. So dividing throughout by 4. So you get here 2h plus 3k is equal to 3. 2h plus 3k equals to 3. And this is your equation number 2 in H and K. This is the second equation in H and K. You understand? Now what you will do, you will solve this equation with this equation. When you do that, you get the value of H and K. You will get the value of H and K. Once you got H and K, what you got is the center. Once you got H and K, you will get the center. After getting the center, you will apply distance formula for CP. You will get the radius, then center radius form. I hope you followed it. Okay, come on. So what is next step? You will solve equation 1 and 2 simultaneously. The next step is you will write solving equation 1 and 2 simultaneously. Solving equation 1 and 2 simultaneously. So when you solve 1 and 2, what you will get? You will get the value of H and K. Okay, solve these two equations simultaneously, get the value of H and K. Once you get the value of H and K, you got the center. After getting the center, apply distance formula for CP. You will get the radius, or you can apply for CQ also, any one of this. Once you got the radius, apply center radius form and get the equation of circle. So I hope you followed it. Do it, complete it now. So students, when you will solve these two equations, you will get the value of H as minus 3 and value of K as 3. So you will write, therefore, the center of the circle is minus 3, comma 3. You will write, therefore, center C is minus 3, comma 3. After this, you will find the radius. Radius is CP. Therefore, radius is equal to CP, and that is equal to square root of x2 minus x1 square plus y2 minus y1 square. See, this is negative 3 and 3. So you'll get here 1 minus of minus 3, 1 minus of minus 3 square plus minus 4 minus 3 square, minus 4 minus 3 square. So you get here square root of, this is 4 square 16, plus this is negative 7 square 49, that is equal to, so you get here 55, 65, square root of 65. This is your radius. Now you will write, therefore, equation of the circle. Therefore, the equation of circle in center radius form. In center radius form. What will it be? Very simple. You will have here x minus h, what is h? Minus 3. So x minus of minus 3 square plus y minus k is 3 square equals to the root of 65 square. Remember, root of 65 square. So this is x plus 3 the whole square, x plus 3 the whole square plus y minus 3 the whole square equals to 65. So you got x square plus 6x plus 9, x square plus 6x plus 9 plus y square minus 6y plus 9 equals to 65. So you got here x square plus y square plus 6x minus 6y plus 18 minus 65. So this is 65, 87, 47. So you got minus 47 equals to 0. This is the equation of circle. I hope you followed it.